Hello, my dear friend. In this video, we are going to implement bubble sort. I would like to tell you something before we start the video. Whenever I stand in front of this whiteboard, you know that I'm going to implement a data structure or algorithm, or I'm going to solve a problem. So quickly grab a pen and a paper with you. I'm not the person who is going to teach you how to solve a problem. Instead, we are going to pair up and solve this problem together. I'm going to think loudly as I solve a problem or implement something. And you can feel free to pause whenever you feel like I am giving too much information away. This guy is saying so much things. I don't want to hear that. I can do it myself. Pause the video and complete the problem yourself. I am so happy for you, even if you don't watch the remaining of my video. Come on, let's jump into solving bubble sort. Sorting is nothing but arranging a set of numbers or words in ascending or descending order. Consider you have an array. So this is a 10 element array. We are going to conceptualize how to do a bubble sort. Bubble sort is nothing but exchanging nearby elements. For example, you have to swap these two elements and then swap the first and the second and the third and the fourth, only if it's in the reverse order. So, for example, if 15 and 23, you will not swap because 15, consider we are doing an ascending order sorting. So, smaller numbers come first and larger numbers go second. Here if you see 15 and 23, they are already in the right order. 15 is less than 23, so we just skip without swapping. So we go to index 1 and 2 and we see that, yeah, this has to be swapped because 4 comes before 23. Let's, instead of talking, we can write it down. First, let's manually solve the problem. I will consider an array 1, 9, 0, 25, 90, 95, 32, 11, 7 and 9. So this is the array and we are going to do the first iteration. We are going to check if it is in the right order. If not, swap. So is 1 less than 9? True. So we don't swap it. Is 9 less than 0? No, we swap it. Instead of 9, we put 0 here, 9 here. 9 is less than 25, true, so we don't swap that. 25 is less than 90, true, we don't swap that. 90 is less than 95, true, we don't swap that. 95 is less than 32, false. So 32 and 95. 95 is less than 11, no, so we swap it. 95 is less than 7, no, so we swap it. 95 is less than 9, no, we swap it. So the new order is 1, 0, 9, 25, 90, 32, 11, 7, 9 and 95. This is the end of first iteration of the array ARR. Even now it is the array ARR. We are not creating a new array, we are just swapping elements within the same array. Now let's, is it ordered? No, it's not ordered. 1 comes here, 0 comes here, 9 is there, 25 is there, 32 is here after 90, it's not ordered. Now we do the same thing again. Is 1 less than 0? No, so 0, 1, we swap it. 1 less than 9, true. 9 less than 25, true. 25 less than 90, true. 90 is less than 32, no, absolutely not. 90 is 90 less than 11, No. Is 90 less than 7? Not at all. 90 less than 9? No. Is 90 less than 95? True. So the new value, I am just writing it again to make it visible and clear. 1, 9, 25, 32, 11, 7, 9, 90, and 95. Wow. Is it sorted now? No, it's not. 11 is here, but 25 and 32 are here. It's not. Let's do it again. It's the third iteration. 0 and 1. Yes, 0 is less than 1. 1 is less than 9. 9 is less than 25. 25 is less than 32. But 32 is not less than 11. So 11, 32. 32 is not less than 7. So 7, 32. 32 is not less than 9. So 9, 32. Is 32 less than 90? Yes. Is 90 less than 95? Yes. So this is the result of third iteration. 1, 0, 1, 9, 25, 11, 7, 9, 32, 90, and 95. Now is it in order? No, 25 is not less than 11. So do it again. 0 is less than 1. Yes. 0 is less than 1. True. 1 is less than 9. 9 is less than 25. 25 is not less than 11. So 11, 25. 25 is less than 7. No, not even in your dreams. 7, 25. 25 is less than 9. Not at all. 9, 25. 25 is less than 32. Absolutely. 32 is less than 90. Yes. 90 is less than 95. Yes. So the result of the fourth iteration is 0, 1, 9, 11, 7, 25, 32, 90, 95. Yes, it is sorted now. How do you say that? Just give one more iteration. You have done 4 times. Why not the fifth time and see if there is any swapping? 0 is less than 1. Yes. 1 is less than 9. Yes. 9 is less than 11. Yes. No, absolutely not. This is where you make mistakes. So you did another iteration to confirm whether it's already in sorted order. It's not. Now you do this iteration again. So 1 is less than 9, 1, sorry, 0 is less than 1, 1 is less than 9, 9 is less than 11, 11 is not less than 7. So 7 and 11. 11 is less than 25, 25 is less than 32, 32 is less than 90, 90 is less than 95. Now the result of this iteration is 0, 1, 9, 7, 11, 25, 32, 90, 95. One more iteration to check whether it works. 0 is less than 1, 1 is less than 9, 9 is not less than 7 again. So 7, 9. 9 is less than 11, 11 is less than 25, 25 is less than 32, 32 is less than 90, 90 is less than 95. Now the result of this iteration is 0, 1, 7, 9, 11, 25, 32, 90, and 95. As I said, one more iteration after you felt you sorted everything. 0 is less than 1, 1 is less than 7, 7 is less than 9, 9 is less than 11, 11 is less than 25, 25 is less than 32, 32 is less than 90, and 90 is less than 95. Final iteration didn't have anything to swap. So you are done with the sorting. Did it feel tedious to do this? Of course, computer also feels the same. It's tedious for the computer too, surprisingly, even though it's a machine. Now, as you understood how to do bubble sort, let's do it programmatically. We are going to implement bubble sort. Void bubble int array. If you are using C, you might need to pass in the length of the array. If you are using other languages, you can get it from ARR itself. To be consistent, I am using the length also. We did multiple iterations, right? So we did iterations till everything was in order. There was no swap at all. That's when we stopped iterating. Int swap count equal to what if you are given already sorted array? Anyway, you have to do one iteration to check if everything is in place. So we will use a do while loop instead of a while loop. When do you use a do while loop? When you have to execute the loop once before checking the condition, and only in the second iteration you will start checking the conditions. So we will have the swap count 0 now. Do what do we want to check? We want to compare each element with the next element, and if it is not smaller than the next element, then we swap it. So for int I equal to 0, I less than n minus 1, you will get to know why I am doing I less than n minus 1, I plus plus. If there are, say, 5 elements, 1 2 7 9 11, okay, consider it is not sorted. Maybe instead of 9 I will keep 12 here and 19 here. Okay, so here there are 5 elements. This is 0th position, first position, second position, third position, and fourth position. So n is 5, 5. N minus 1 is 4. Okay, till fourth element we are comparing. But why did I not put I less than or equal to n minus 1? Instead I put I less than n minus 1 is because our current position is starting from I. So when comparing the last element, our I will be 3. We will be comparing with the next element, which is I plus 1, and that will be, so we should be in n minus 2 to compare with n minus 1. So if we did a less than n or less than or equal to n minus 1, then our I will be 4 and we will be comparing outside the bounds of the array. Here what will we check? We will check if the current element is less than the previous element. If it is greater than the previous element, we swap. If current element, which is ARR of I, is greater than the next element, ARR of I plus 1, if it is not in ascending order, if the current element is greater than the next element, then we swap. Swap which one? Swap the array elements I with I plus 1. If not, we don't do anything. But you remember, when a full iteration doesn't have a swap, then it means it's already sorted. So instead of swap count 0, instead of putting swap count 0 here, we will define it, we will assign 0 here. After every complete iteration, we will make it 0. Swap count equal to 0. Now if we did a swap, then we do swap count plus plus. You can just have a boolean instead of this one, but certain languages like C, we don't have an inbuilt boolean, so I used integer, and you can use the count for anything else if you are solving a different kind of problem. you are free to use a boolean here. If the current element is not greater than next element, we don't do anything. If it is equal or if it is less than, we leave it there. When while swap count not equal to 0, when swap count is not equal to 0, we do it again. That means whenever no swap happened across one full iteration of the array, then this will become false. Swap count will be 0 because we initialize it here, and if it doesn't increase the count here, then it will still be 0 and come out of this loop. There is nothing to return, so this is a void function. See, you can put manual calculations and see whether this will work. What did we do? We just checked the whole array once. If anything swaps, we swap it and increase the swap count. If there is no increase in swap count, we are done with our sorting. So what is this swap function? It's a very simple function. Void swap int arr int I comma int j, int k equal to arr of I, arr of I equal to arr of j, arr of j equal to k. What am I doing here? Consider an array. You are going to swap these two elements, which is in index 3 and 5 or 3 and 4. In this case, we are just comparing the nearby elements. What do we do? Whatever is in I, this element, example 5, this is 3. Okay, I am just taking this element 5 in k. Now k equal to 5 because arr of I is 5. Now in the place of arr of I am putting j. So instead of 5, I am putting 3 here, and in the place of 3, I am putting whatever is stored in k, 5. So I have successfully swapped 5 and 3. This is such a simple implementation, even though it was tedious during manual calculations, but it's definitely very hard for the computer if the array length is so huge. If you have 1 billion elements in the array, it will take forever to complete this, because for every element, for we are doing multiple iterations of the array, we are essentially doing n comparisons each time, and the maximum number of comparisons if everything is in descending order. If the array is completely in descending order, that will take n number of iterations. So this is a O of n square algorithm. This is very time consuming, and your computer will struggle like a child. Hope after the manual calculation you tried out yourself in implementing this successfully. Even if you got stuck, don't worry, I am here to help you. You might have understood it very well now. If you use the video to implement it, definitely take a fresh page and write down the implementation yourself. You are going to hit the skies with algorithm learning. Algorithm is going to play a crucial part in enhancing your career and making you get higher salaries and a great job in the future. Thank you. Hey friend, are you still watching the video? Then I would like to give you a gift. I have created a free guide that breaks down the most common data structure and algorithm patterns. Instead of telling you how an algorithm works, this guide tells you when to use it. Do you find yourself wondering which data structure or algorithm to use in a particular situation? Then this guide is definitely for you. Grab the guide by clicking the link in the description. Until we meet the next time, this is Shivakumar aka Algo Shiva signing off. Bye.